Yes, hello, welcome here at this talk about AI-driven code refactoring. As the last people are still coming in, I'm already getting started. Hi, I'm Jorrik Klijnsma. This is me. This is also me. This is me looking at some nice servers. This is me playing some saxophone. This is me doing very looking into the distance type of shoot. More me. This is me doing actually AI research. And this is me next year in Hollywood. Yeah, as you can see, AI, you can do a lot of fun stuff with AI. But the real me is here, so these were all AI-generated pictures, just to get started. But to know me, you actually have to be here, or see me, or talk with me. A part of me that is interesting is that I'm from the Netherlands, so the other side of the world. It's actually my first time here in Australia, so it's really nice being here. I'm planning a little road trip after this conference at the Great Ocean Road, so you probably all know that, done that. I'm not sure how that goes here. I'm a software engineer, front-end engineer to be specific. I work at a company called Soprasteria. We're a European company with around 60,000 people worldwide working for Soprasteria. Like I said, I did a holiday, took a holiday after this conference, but also towards this conference. I traveled from Amsterdam to Melbourne, and you fly past a bunch of countries, also some beautiful countries, and I stopped in one of those countries to have a little holiday. And that country was Thailand, and you will see more about that in a moment. So enough about me. What I'm gonna show you today, I'm gonna do a little bit of an introduction. Then I'm gonna talk about different phases of automated code refactoring using AI. And then we're gonna conclude with some best practices and some conclusion. Coming back to the Thailand holiday trip. I was there. I actually was there at the resort, and next to the resort they had this nature reserve, and they had some monkey trail tracks, which they called them. These were tracks that walked past a cliff, and you could just walk there towards the next beach. And this was called the monkey trail because this trail was next to a piece of forest where all kinds of monkeys hang out. And these monkeys like to come over to the trail, annoy tourists, get food out of their bags, and yeah, that was very fun to walk on this trail, see some of these monkeys. But while I was walking there, I also noticed something, like they built this track using bamboo, wood, very durable materials. But these materials are maybe not as strong as some other materials that are less durable. The weather can be a bit of an issue there, with storms and not everyone being as nice to the stairs as they should be. So every once in a while some of these stairs break, and it was the only route by foot from one beach to another. So they fixed these stairs quite quickly. And because the amount of bamboo and wood available, this can be done very easily. And I was actually walking there. I'm going to show you a little video clip. What you will see over here, this is just the track is how it goes. On the left, you see a part that actually has been damaged, and they just build a section around it, just a bypass. So here you see something that basically is some kind of refactoring or going on. So here you see the broken part of the previous path, and they just build the current path around it. was probably done very quickly because these stairs were damaged and they needed new stairs. But you can actually see how they really like build platforms and just bypass the whole section. I found that very funny because this feels very much like some code where people walked into an issue and said, I can pick up this issue or I can just go like this and solve it in a different way. And that works for some cases, but it doesn't always work. And it doesn't work always in the long run. Sometimes when you're using a project for a longer time or entering a new project, these type of code things exist, where there's legacy code, things that once made sense, or they need a fix for something and didn't follow up, and this tech debt start building up. You might want to refactor that. This is one example of why you want to refactor. There are more examples where you say, we are using a system that's going to lose support soon, so you might want to refactor. Maybe there are other things at play, but I think this is a fun thing to show and to understand why code refactoring can happen and why you would want it. Instead of all these bypasses, I think there's a better way to do that. And we probably all have seen code where you think there's a better way to do this. And that's where we can use AI to refactor that piece of code, or maybe even whole code bases. I'm going to show you a couple things about refactoring using AI. But I like to say that if you have any questions, please raise your hands. You don't have to need to wait to the end of the presentation. Feel free to ask along. If you understand it, I'm happy. So let's go for that route. And I think this is also some kind of cocktail. We're going to talk about the phases later on. And you will see that some of these steps, some of these phases are also useful for things you do outside of code refactoring. They can be useful in general. So take what you want from it. It's not always code refactoring that it's going to be useful for. So yeah, be aware of that as well. Considering legacy code, there are some pain points that can be really bothering you. Things that are undocumented, variables that go all over your code base, things that doesn't work as intended, patterns that were useful a long time, but just like we see with the monkey trail, and workarounds that can be manual, not always for the long run. Mixed responsibilities are things that can exist in legacy code. Warnings that can be commented instead of proper solutions, so fix this later, or these type of things, to-dos. Hard to maintain code without breaking something, stuff you don't want to touch, otherwise the whole thing is going to set on fire. I think we all know these kind of code bases or these kind of projects. So who has never had experienced one of these pain points in their developer life? I'm going to put my hand down, but yeah. I think most of the room, almost everyone, has at least met one of these pain points. This is an example of a project I worked on. A project which we got to take over from another team, and this project was built as a POC, a proof of concept. And yeah, what you should do with the proof of concept, if you have made it, you wrap it up, throw it in the garbage, never touch it again, and just start again from scratch to build it for production. That's how the textbook says you need to do it. In the practice, in daily life, that's not how it works. So this project also started as a POC. then became a production project. And these were one of the very clear examples to me that there was a lot of legacy code happening. When I searched for the exclamation mark important in the source folder of the project, it was a Vue project, there were more than 250 uses of exclamation mark importance. As a front-end developer, this is something you don't want to see very often, as it is most often an example of a bad practice in place. What even happened was they had the scoped to the CSS style tag often not there. So when a component would be loaded, the CSS for that component would count for that whole page. So this resulted in some pretty heavy issues that we had to fix. And yeah, this was a project where we were not allowed to use AI at the moment, so we had to do that manually, going over all these important, check how to solve them. But these are things I would wish I had an AI refactor at my disposal. And actually, some of the things I'm going to show you are a result of things at the project. And it was actually one of the first things I did using AI. When ChatGPT came to existence, like 2.5 years ago or so, the first thing I did, I had created a Vue project, a website, a personal website to help people with dyscalculia, to translate an analog clock to how you would say it out loud. So if you see the handles on a clock, what is the text you would say for that time? I had made a Vue app of that, but an offline app on your iPhone would work also very nice in situations where you don't have internet. So what I did very early on, one of the first things I did with ChatGPT was take that code from that Vue project and translated that into a working iOS app. It took me a weekend because at the time coding was a bit hard using AI. It gave a lot of errors. But my recent error rate using Claude 3.7 or the latest models, like it dropped massively. Like I rarely get any error messages with the code it generates. So you see the improvement of AI code, and this also goes for example the refactoring. We're refactoring now, taking that piece of code from one state to another, using AI can be so much different than it used to be. It was a very manual process, refactoring, going into the code, seeing what needs to be done, and then just applying those things you figure out to the code to change it to the new one. This results in a 90% drop of time you spend on refactoring code. It can be really that efficient, and we're going to see some of that later on today. So this is about the introduction of AI refactoring, and I already mentioned a couple times the 4 phases of refactoring. And I'm going to share them with you. These are phases of refactoring that I turned into AI steps, and we're going to go over them a little bit more into detail. So phase 1 of refactoring code is to gather some insights. You want to know what for code base you're dealing with, you want to know what for components, what is the whole landscape of the thing you want to refactor. And in phase 1 we are looking into that, understanding the code before we're going to change it. In phase 2, we're still not refactoring or changing anything. We are preparing the change itself. So for the change to happen, we have had the insights, but now we want to make sure the change will go as smoothly as possible, mainly using all kinds of testing tools, and make sure that we have a strong foundation, a strong idea, a strong plan to make the change happen. Then we go into actual transform phase, where we making the changes to the code, to the components, to everything, to switch it from the old state to the new state and see the change of the actual refactor happening. And then we have phase 4 where we just have a check, have a look, go live, make use of feature flags, all these kind of things, and verify if the change happened or the refactor happened as we would like it to happen. Now we're going to look into these phases separately a little bit more into detail. Phase 1 was the gathering insight phase. And here we're dealing with sometimes with a kind of a black box problem. When you receive a code base or a component you need to refactor, you first need to understand the project. And this can be a new project. You're lucky if you're already for a long time in this code base, because then you probably already know a lot of it, of the code base, know where to look at. But if you're going to use AI, AI doesn't know your code base yet. So AI still, for AI, your code base is still a black box. But it can be for you as well, depends on your situation. To deal with that, we need to figure out what this code base is all about. We have different approaches that people are common with or people use. These are, for example, line-by-line reading, just going over the code, documentation review, see if there's some documentation. Luckily you are, that's not always the case. Maybe map out some functions, add some debugging steps to see how the code behaves at certain levels. Use some analysis tools to see what's going on, for example, code coverage, all these kind of things where we check how much of the code is actually covered in the tests, but also see how much relations there are between functions. Are we dealing, for example, with functions that are exported in the file, so can be imported elsewhere but never used elsewhere? All these kind of analysis we can do. And also make some architectural diagrams or have them. These are all approaches that you need to take to get insights into the code base. And manually they can cost a lot of time, especially if they are not there. So if these things are not available, for example, the architecture diagram, if the project doesn't have it, or the code base, then yeah, it might take some time to make that. I'm going to show you a little demo today. So I've created a little application as an example, which we're going to use to showcase the refactoring. Close this. Here we have it. Yes, we are using this example application. It's a demo application. It's a trail body. You can see which trails there are, how the trails are going, some more information on the trails itself, some details. We have some dangerous tracks, which we want to know about, why they're dangerous, and just some information on these tracks. If we're going to have a look at the code base, it is this, let me zoom in a bit. This is how you would go to see how a code base would look and check how does it work to get an understanding of this code base. We see it's a project using Vite, React, Tailwind. So these are things we now know the project uses as dependencies. We see here stuff going on in the app. There's already some trail provider. We're dealing with some styling, trail status. Okay, seeing things going on. The trail status seems to be part of the main screen. I already see like clicking through can be hard to process, see what's going on. And to go over a whole code base, this is a very small code base. It only has a couple components. But if you need to do this for a whole code base, this can be very exhausting. So instead of clicking around and showing you where everything is, what it's using, what does this trill detail component do, we can use AI to take some of that out of our hands. So using AI as a code archaeologist to really dive into the code base, see how the code is structured, and deal with it. We're going to have some analysis workflow. This workflow exists on a couple of steps. The first step is to get some metadata from the project. The next step would be to map out some of the structure of the project, to understand how the project is built. Then do some file analysis. For some files we want to have a little bit more information. For example, a component, you want to know what's in the component and what the component does. And we also might want to summarize the whole code base in a neat overview. Going over these steps. Step 1, get some project metadata. Here, what you see is this is the project we are using, that monkey trail project. Here I've created a little script. And this is just a script that takes some different project types, and it detects the type of project, and you can extend that. But I want the metadata from the project. And for a React project, we are going to need the package.json. So as an input, I have the folder where I'm hosting the project. Let's go to that. Oh, there. So I'm going to run this script. Let me remove the output file. And this script just analyzes some data. It's just regular scripting, no AI happening. It just looks at different files, checks what type of project it is. In this case, it finds it to be a TypeScript project with a package.json, and it can get some information from the package.json. For example, it gets the name of the project, some tools that are being used. It detects what type of React version that can be useful later. And it also lists some first-level directories in the source folder, because these can also be relevant. And just have some summary of what the script found and when the script was run. So with the script, we already got some first steps out of the way to see that project metadata. Next up is the project structure, and I'm going to show you that as well. Remove this. What we do is we have the input again. Sorry. And what we do with input again is just the folder name. We take that file, we generate all the paths of the components that are relevant for this type of project. So in this case, we are dealing with the React project, and we are having to check all the files that are relevant. For example, TypeScript files, component files, JSON files, and we just want to list those as like what we got from scanning the project. This is all again just a regular scripting, no AI going on. But these are steps to gather information on the project, which we can feed to the AI. So I'm going to run this script now. What this script does Like I said, it outputs the project structure in a readable format. So it shows for every TypeScript file, every JSON file, and every TSX file, those are the components, where they are in the project, and it just walks, traverses through the project, see which of the file types, which of the files it finds, and if they match the file type for the project, and then just adds them to this meta or this project structure analysis. Now we have those two things. So we know what kind of project we're dealing with on a high level, what dependencies we have to deal with, and also what kind of files we are dealing with. To make it a little bit easier for the AI, instead of needing to parse all these interesting folder structure formatting, we also used exported directly an output with all the same files, but as a path. So that's easier to handle for the next step. Next step is the analysis step. We're going to analyze every file that we found in the previous step. This is all just gathering information to know what project we're dealing with, and to give that as context to the AI. So let's remove the analysis folder. We have an analysis file script. What that does, it takes information from the input. That is the analysis we did in step 1 with the metadata. In step 2, we figured out all the files that are relevant for this project by their file type. We put that inside of this script. What the script does, it has different prompts for each file to get some information of that file. And this prompt contains a placeholder where the content of the file gets put in. Then it's using that to make some small analysis. And we're going to have a look at that. Then for every file in that input file, it's going to run that prompt and check what it's found, what the file looks like, and just write down some basic analysis in a short format, so we can feed that later on to the AI for the relevant prompts that we're going to use. Again, this is just a script that loops. The AI magic is happening here. Let's take an example. This is the prompt being used to analyze a TSX file. It would check the file. It would get the file path from the it gets filled in the script. I want to know some information about this component. I want to know where for what it's used, what it returns, what are the input options, all these kind of things. And I'm then also using the placeholder to share the file's content. And it's going to do that for every file type I define here. And the script is just going to over that input list and do that for every file. For this, I used a local AI using Olama. I'm running Qwen 3. Now when I run this analyze file script, it's going to go over every file and run that prompt for that file. This one. And this is going to take a little bit because I'm also hosting the presentation. But it's now talking with Olama in the background. It's giving it the prompt, for example, for the CSS. It's going to place the file content in there, and then it's going to return something. You already see we got the package.json analysis back. So what we see here, the AI returned some information. It says the file purpose for the package.json. It shares some configuration file, and if we match this to the prompt for analyzing a JSON file, we see we want the file purpose. We want to see what type of file it is, because it can be a package file, it can be data, it can be a config file, so we want to know what's going on. If it has data, we want to know this about the data, and if it's another type of file, we want to know this. So now looking at this package.json, I'm seeing the AI extracted some information. Not sure why it picked at number 10. Maybe because I talked about the 10 lines. But you see here, it's just figuring out what this file does, this package.json, what's in there, just relevant information. It also does that for example, TSX files, the components. Here is that the component analyzer prompt. Again, we put the code from this specific component in this prompt, send it to the Olama, and then it explains to me what is the component about, what input outputs it has, and that results in a nice detailed overview. And now if I'm displaying that here, this is way more readable and concise than every time sending over that component and all the code to the AI. But if you need, for example, have reference to other files when refactoring one component, you might want to add these files with a more concise text, a more summary, instead of adding all these components with the whole code. So this is just to get the information for every part of the code base to use later on. I think it's still running. We're going to let it run. And it does that for every file that I've given it. This is a nice way to get that information. Now, using that information, we can also build like a final code base summary. And we can do that, for example, using the metadata from step 1, the file structure, the file analysis, and then we can build a whole analysis of the whole project. To do that, I'm going to use a different AI because my local Olama doesn't have enough context to do that at once. So over here, I'm using, in this case, Gemini. Now let the temperature stand. Okay, so here I'm putting in the prompt, and now I just need to replace this. This can all be manual, or this can all be automated, but for the demo purposes, I will be showing it what the steps do. So I'm taking this project metadata from step 1, going back to step 1. That was this information. I'm going to find here the project metadata and pasting that over there. Now I'm going to the project structure. Again, that was this file. Replacing that over there. And now I'm going to paste in here some of these analysis files. Let's do the package.json. Let's do this one. Yeah. This one. A couple more. Just to give it a nice overview. So now when we run this prompt, it will start analyze the whole code base based on the information you provide here, and makes a nice documentation of that whole code base. Also, we're gonna let this run for a while. And this is the last step of that first phase. So here we got the information from the code base. We brought it down to different files that we can use later on.
Is this example available somewhere on GitHub?
It is in a private repo at the moment. I can make it public, but then I need to structure it with a bit with the prompts. But I think that I can send it over. For example, in the Slack with of this room. So here you see it generated application overview showing me what the project is about. And this is some documentation that otherwise took me maybe hours to write or to come up with. And we just did it with some prompts in a couple of minutes. And you see how this already shows way more information that I would be able to get in the same time clicking around in that code base. This is actually also very helpful information for the process of refactoring, because this is context we need to know when we want to refactor some components or whole code bases. You want to know patterns used. We want to know what components there are. For example, if we are going to refactor a component and it's referencing other components, you want to be able to know how to approach those, how to implement those. So here you have a nice overview. Going back, so we are gonna refactor one of the components, and we're gonna refactor the trail list component. This component has some issues, has some poor TypeScript usage, some class component versus functional component is different than the rest of the code base. And I'm gonna use this component as an example to refactor using using AI prompting. And I'm going to do that, prepare that in the next phase. So this next phase, I already said, is about building like the road to the refactor. What needs to be done? How can we validate that the refactor has been successful? How can we make sure nothing breaks along the way? That's why we need to write some tests first. Because tests are going to be your steering wheel, know what's going on, see where things break, because with refactoring, almost every time you want to keep the same functionality, because it's not the functionality that needs to be refactored, but your code that is like we saw at the beginning. So we want to make sure we kind of set in stone how the project or the part of the project now works, and then we can change it, and then we can keep seeing if it still works in the same way. This is also where you have to deal with maybe stakeholders, because stakeholders like tests, like metrics from tests. Yeah, an example is how test coverage, it can be very useful, but also can give wrong images. Wrong ID. So I think it's very appropriate to choose which test are we going to use. How do we make sure that we are keeping the same functionality and not testing to just be testing. Some traditional testing approaches are end-to-end tests, unit tests, and these are different for each project, but we're going to also see in the prompts how we are using the libraries for that project. For AI testing, we want to see how the component behaves. We've done that in the first step. We want to identify test scenarios to see what do we need for this component to be tested, but also edge cases. Maybe you want to have performance in there, performance tests. Then we want to generate a test plan to see what do we need to do, which tests and which ways we need to write the test, and then actually create the test code to be able to run it for the next steps. I'm going to show you a bit about that as well. Yes. So here we go. We are going from phase 1 to phase 2. Here I have a couple of different prompts. Let's first start with the test plan generation prompt. This is a prompt that again takes some information from the previous steps, previous phase. We add it in here, and then it creates a whole test plan. And we want different things for it to show, to write edge cases, to write different tests, and just be complete in what you need. For this, you also see I have some refactoring requirements. Here I have an example. This can be a shorter description on what do we need to be the standards for the new state, and it's just a list, just a file with information on what implementation we would like the new code to have. So I'm going to use that test plan prompt. I'm going to give it all the information that we just gathered. Can I clean this? No, let's start a new chat. Okay, so like I said, we are going to use that list component. This has some issues, and I wanted to identify that, but to make sure that we have a well-working component at the end, we first want to get those test results. So I'm pasting the information here. Then I'm going to give it the requirements for this file, which are these requirements. And this can be different for each project. It depends on which project you're working on. And I'm going to give it a couple of relevant. Lost my placeholder. Here it is. I want to give it some of these relevant sections from phase 1. What it's going to be is, in this case, I'm going to give it the trail context and the trail type, because that is referencing those two files. So I want those files to be part of the prompt I'm providing. There's the trail and the trail context. This is the information that we got from the trail context, and the information we got from the trail types. Like this. So now I'm going to give it this information and start. I'm running the prompt, and it will analyze the things that I fed to it. It will come up with a testing strategy of how we can test this component. And this is an example of something that can be more useful than only refactoring, because this you can already do on new components or components that don't have tests but don't need refactoring per se.
Do you generate the test before you do the refactoring?
Yeah, so good question. The question here was, do you generate the test before you refactor? I would say yes, definitely, because you want to also validate to the current way of working, because very often with these code refactors, you want to have the end result stay the same. So if it works, if the tests succeed in the current result, you want them to also succeed in the end result. So if you make them up front, you can keep that consistency. So this is a very elaborate testing plan with all kinds of information. It made the analysis, what functionality to test. It wrote the test cases. This is a very detailed overview for the component that we're dealing with. So all this information can be put inside your code base. Of course, I think it goes for itself, but it's important to always check these codes. Don't just copy paste it and use that in definitely not in production websites. If you're vibe coding for hobby projects, if your credit card is large enough, then feel free to do so. But it's very good to understand what the code is doing, so you don't end up with the code do weird things or have leaks in there or something. Also, this maybe also goes without saying, but giving AIs these kind of information, it depends on the situation if you are able to do so. A way like writing these test plans can also be with anonymized information, or you're just filling in, I have a component that does this and this and this. I want to write a test plan, a test schedule. How would I approach this? It also goes for the next one. These are things that where you don't need the actual code to send over to the AI, and it is also able to generate just the structure or the IDs, which you then code yourself. So that's a level higher where you might be able to use AI to get a bit faster instead of using the actual AI code. So this is the test result that came up with the test plan. But with testing alone, we don't come very far. So we also have the refactor plan. In this refactor plan, it plans out what needs to be refactored. It identifies the weaknesses of the component. What does it need to? What standards does it need to meet? And I'm going to build the same file, of same type of file. So here, using somewhat of the same structure. Again, going to step 1. Let's start with the requirements over here. Let's pick the short one. Please. Copy. Yes. Over here, again, those two files, those were the trail with the types. I'm giving it that information, and I'm going to give it the trail context information. Would be nice if you actually work along. Yes. And then we're going to paste the component itself again. And that was the list. This is the part where it creates the whole plan, the whole idea of what needs to be refactored on this component to meet the new standards. What do we need to change? And it analyzes that. This prompt just takes all these output steps you wanted to have. So a step-by-step plan, new structure, code that we might want to send to a new file or have in a new file. The dependencies the refactored component will have, if there are new type definitions, maybe challenges for the refactoring that's going on. And you already see, even if you're not allowed to use AI in your project to generate code, maybe this is an option to get this information automated from an AI. Run it on your code base, see how we can change these files or parts of these files. Let's see what it came up with. So here we see it approaches like we want from a class component to a functional component. We're gonna change how we use the states of React, the hooks. Maybe want some function logic extracted. And here you see a whole detailed list of how we want to refactor this code, and a step-by-step plan on what to do, how to execute it. And this would already, like, if you have this and then do it manually, make these changes, that already would help you very, very much on refactoring such a component and not looking into this for every component again. So here you see how the new structure would look like. This is the refactored component. It adds some new utils to the util file. Also want to add some types to the type definition. So this whole plan is very extensive, very elaborate, and very useful into refactoring such components. Again, if you need to write this yourself, identify all these things, it's going to take some time. Okay, so with phase 2, what we did, we built the safety net, these test approaches. How do we want this test to be? What do we want tested? We wanted to set some boundaries. What does it need to meet? The new standards, the new criteria. We documented some of the behavior in these analysis. This is also a part where we could have had performance benchmarks to say we want to meet this standard of performance, which I skip now for time reasons. Now we're going actually to the transform phase, where we actually start to change the component itself and do the refactoring. So again, here I have a prompt that I'm going to feed with some data. We're going to move to phase 3. Here we're going to use actually the code itself to refactor that. So here again, I'm using this prompt. What the prompt does is it's going to use original component code, refactoring plan, again relevant component structures, related descriptions of these related files, and the requirements we want the code to have. Now I hope I did not override my Okay, then no. I should have copy-pasted the previous output. Let's see how I'm going to fix that. So again, I'm giving it the requirements. I've done the copy-paste. Somehow my keyboard is acting weird. I'm going to skip the refactoring plan for now. Of course, you want to give it that refactory plan, but I think for such a minimal component, it would work without. So let's see how it does without a more detailed plan. So this prompt, like I said, took all the information we generated, and then it's just gonna execute it, refactor that code you give it. And here you see it already started to extract some of these utils that it talked about in the previous phase. Although we did not provide it, it was smart enough to see it on the component. We need to extract this. Here we got the component itself refactored, added some documentation to it, or like inline comments. This would need a lot of reading through, because you want to make sure that what happens is what you want it to do. But at a first glance, it looks like it did a good job. It did some of the things we asked it to do. It explained the decisions. I added to the prompt to make sure that it thinks about it, that it explains what it does, so you can more easily check if it does what you want it to do, and all this information. So going from phase 1 to 2 to 3 took us around half an hour. And we're already at a point where you would maybe take a day if you would need to do this manually. The last phase is a phase to validate, see if there are still bugs in your code, so run your tests, maybe add some feature flags, do some manual review, do the performance benchmarks if you have them, if they're relevant for your project. Maybe do some official regression tests. Does it actually stay and look the same on your web app? Maybe have a deployment plan, or just follow your regular release structure. Let's go very quickly on some of the best practices with this AI code refactoring. AI can work on every project, but currently I don't think AI should be allowed to work on every project. So be really aware that you're adding AI to your project, or that you're using AI. Does it fit the project? If you're dealing with user data or with sensitive data, be aware of that. Do some input validation on your, test your prompts, see if the things that you put into it are things you wanted to have. Add some error handling, so in your scripts add parts where it allows you to see what's going on, what messages are being sent to the AI. Check dependencies that are changed, so if it comes up with new dependencies, make sure they are useful, but also they are valid dependencies and meet the standards that your project requires. Start small. I think it's nice to get used to this, to use it on smaller personal projects, maybe internal tools, just to get known how to use these approaches of refactoring using AI. It can help you also understand it, but also maybe revisit that old project of 10 or 15 years ago that you did. I think that was I wanted to tell you about AI code refactoring. Already got some questions. I also see it's time, so if you still have some questions, I will be here or there at the break we now have. So thank you very much.